number. Let's talk about alkyl groups. Alkyl groups usually have one less hydrogen than any carbon group of hydrocarbons. So for example, methane hydrocarbon has 1 carbon and 4 hydrogen, CH4. So methyl group would have 1 less hydrogen, meaning instead of having 4 hydrogen, you will have 3 hydrogens. This is not a minus sign. It's an open bond. This bond will be used to attach to a carbon parent chain. We're going to talk more about it. If you look at ethane group, you have CH3, 2 carbons with 6 hydrogen, but ethyl group will have 2 carbons, but instead of 6 hydrogen, you are going to have 5 hydrogen. So the 1 hydrogen that is missing, instead of that hydrogen, we're going to have an open bond that can be used to join this ethyl group to a different carbon chain. Propane, we have 3 carbons, we have 8 hydrogens. Propyl group, we are going to have same 3 carbons, but instead of 8 hydrogens, we're going to have 7 hydrogens. And the hydrogen that is missing, we're going to have an empty bond, and that bond is going to be used to join the whole group into a new chain. You don't have to memorize that alkyl groups will have 1 less hydrogen if you focus on the summary that we talked about in our previous lesson. So if we focus on the summary, we don't have to worry about memorizing anything. So why don't we try and practice some questions and see how it goes. So let's draw 3-methylpentane. I understand that we haven't learned about drawing alkyl groups, but at least we should be able to draw pentane. Please pause the video and draw pentane and check if your answer is correct. So for pentane, pent means 5 and A and E means all single bonds, right? So I drew 5 carbons, all of them are attached with a single bond. Now, I'm not done yet. In my 3rd carbon, so I can count it from left to right or right to left. You get to decide, and when you decide, please draw it right away. So for my 3rd carbon, I have, so let me count it from left to right. I have an additional methyl group. So what is the prefix meth stands for? That's what we need to focus. If you're focusing on the prefix, meth stands for 1. So that means we have 1 additional group in this carbon chain. So pentane is our parent chain. Methyl, it's an additional group. So in our 3rd carbon, we have to draw that additional carbon. Please keep it simple and straightforward. So you can draw it at the top or bottom, doesn't matter. And that's what you need to have while you're drawing the alkyl groups. Once you have this set up, everything else will make sense and it should be straightforward. All we have to do is draw the missing bonds for each carbon. Each carbon must have 4 bonds. So let's draw the missing bonds for every carbon. So the 1st carbon has 1 bond already, so I'm missing 3 more bonds. The 2nd carbon has 2 bonds already, so I'm missing 2 more bonds. For the 3rd carbon, I already have 3 bonds, 2 red and 1 green, so I'm missing 1 more. 4th carbon, I'm missing 2 more. 5th carbon, I'm missing 3 more. Now for the green carbon, I have 1 bond already. This is a bond. And it's right here. So I'm missing 3 more bonds. So I should be drawing those 3 bonds. And then all I'm missing is hydrogens. So I have to draw hydrogens for all the carbons. So I drew all the hydrogens, but I drew hydrogens from the methyl group in a slightly different color, which obviously you don't have to do this. However, the reason I did it, because I want you guys to realize that if you focus on methyl group, what exactly do you see? If you focus on the methyl group in the third carbon, you will find that one carbon, which is right here, and then 3 hydrogens, which those 3 hydrogens are right here. And what else do we see? We see an empty bond, and this is the bond that they're talking about. So this is the bond which will connect the methyl group to the parent chain, in this case, which is pentane. So keep things simple and straightforward. Draw the parent chain first, the way you have learned in our last video, and then draw the additional group by counting it properly and using reference table P. So let's try to draw 2-ethyl pentane. I'm not going to focus on 2-ethyl part, instead I'm going to focus on pentane. So pent means 5, A and E means all of them have single bonds. So I drew 5 carbons in a single straight line, and all of them are attached with a single bond. Then I have to focus on number 2, which means I have to figure out where is my second carbon. So you can count it from left to right or right to left. It's up to you. So if you count it from right to left this time, this is your second carbon. This is where we have to have an additional group. What additional group? In this case, we have an ethyl group. What is an ethyl group? Let's go back to reference table P. Eth stands for 2. So that means we have an additional 2 carbon group, right? A group of 2 carbons. So in my second carbon, I drew 2 additional carbons, right? In a single straight line. So it is extremely important when you're drawing something as a beginner, you should always draw things in a single straight line. So for my second carbon, I would draw both of them in a single straight line. Then I have to add additional bonds for every single carbon. So each carbon must have 4 bonds. So for the first carbon, on my right side, I have 1 bond right here, and that means I need 3 other bonds. For the second carbon, I already have 3 bonds. That means I need 1 more. Third, I need 2 more, 2 more, and 3 more. For the ethyl group, I notice that this carbon right here has 1 bond, and here is another bond, so it's missing 2 more bonds. And the carbon right here is missing 3 more bonds. That's what we need to do. Once we're done with this step, we have to draw missing hydrogens. So you don't have to memorize what methyl-ethyl group is if you know how to use your reference table P. I don't have to memorize that ethyl group is CH3, CH2 with a dash, right? All I need to know is if it's eth, I'm going to draw 2 carbons. But first we need to draw the parent chain, and then, which is pentane, and then we're going to draw the additional stuff that is given to us in an organic compound. It is important for you to understand that the drawing that I have right here is not 2-ethyl pentane, where let's assume that a student did this and the student had the first carbon here, second carbon here, third, fourth, and fifth carbons are right here. But in the second carbon, the student knew that they need to add an ethyl group. So what this student did is added a carbon. Eth means 2 carbons, so added a carbon at the top and then added another carbon at the bottom. This is not correct. If you are adding an ethyl group, you need to have both carbons in the same exact straight line. Because in this case, this is not 2-ethyl pentane. Instead, it is 2-2 dimethylpentane, where in the second carbon I have two different methyl group in a pentane chain, where I have 5 carbon producing the parent chain as a pentane. So this is extremely important. When you're drawing things, if it's ethyl, draw them in a single straight line. If it's propyl, draw them in a single straight line. Do not break them apart. Let's try to draw 3-methylhexane. So if it's hexane, first thing I would do is, since it's hex, I would draw 6 carbon. Since it ends with ANE, I'm going to attach all carbons with a single straight line. Again, it is extremely important for you as a beginner to draw everything in a single straight line. So once I drew the parent chain of hexane, now I can focus on the alkyl group of meth or methyl, which is supposed to be in my third carbon. So I have to decide if I'm going to count it from left to right or right to left. Either way, it's going to be correct. So I'm going to count it this time from right to left. 1, 2, 3. So that's my third carbon where I'm going to draw it. Then 4, 5, 6. Someone might count from right to left as well. Once you're done counting, in your third carbon, you have to draw methyl group, and meth means 1. So I'm going to draw additional carbon, and that additional carbon is going to be my methyl group. Once I'm done, I have to add bonds for every single carbon by making sure that each carbon has 4 bonds. So in my first carbon, I'm missing 3 more bonds. Second carbon, I'm missing 2. The third carbon, I'm missing 1. Fourth carbon, I'm missing 2. Fifth carbon, missing 2. Sixth carbon, I'm missing 3. I'm also missing bonds for the green carbon, which is an additional group of methyl. So I should draw the additional bonds. In this case, I have 3 more bonds. Then I have to add hydrogen for each of those empty bonds, and that's the most boring part, but you have to do it. What I need you to understand is the 3 hydrogens which are marked as a green. Those are part of the methyl group, which happens to be in the third carbon from the parent chain of hexane. So please do not combine these 2 hydrogens and draw them together, because that's a common mistake. You have to draw them separately. That's why I usually draw the empty bonds before I add hydrogens to it. So after watching this video, you should be able to name and draw the compounds at this point. So please pause the video and try to name the 2 compounds that are posted here, and then check your answer. So for the first one, I noticed a triple bond, so the name must be YNE, and there are 5 carbons, so the prefix must be pen, and therefore the name could be pentyne, or you can write 1-pentyne because the triple bond is in between your first and second carbon. For the second one, I have a double bond, so I wrote ENE, and then I noticed that I have 4 carbons, so the name would be butene, or someone can write 1-butene, where 1 is indicating the location of the double bond, which is in between first and second carbon. So 4-pentyne for the first question and 3-butene for the second question would be the most common wrong answers, because student most probably counted from left to right instead of counting this one from right to left. So please be careful. Always count it twice. Count it from left to right and then count it from right to left, so that you can figure out the lowest possible number that indicates the location of the unsaturated double or triple bond. So this is a summary where we're missing number 3. So the summary is exactly the same, but since we learned about alkyl groups, for number 3, you should always include any alkyl groups before drawing hydrogens. So remember, always draw the carbon-carbon chain by looking at the prefix from table P, Then look at table Q to figure out if it's all single bonds or double or triple bond. Then look at the location of this double or triple bond if there is any, and then place the double or triple bond before moving forward. Same thing for alkyl groups. If there is an alkyl group, they have to give you the location. If not, you're going to assume that it's in the first carbon, and then you have to draw the alkyl groups. Finally, make sure each carbon has 4 bonds, and then draw all the hydrogens. And that's about it.